We're going to go ahead and look at section 3, which we're going to be looking at the discriminant, and we're going to be taking a look at using the quadratic formula. Now, we talked about how graphing gives you a nice visual of where your solutions are on your x-axis, but sometimes it's approximate. We looked at factoring, which gives you exact answers, but doesn't always work. Completing the square always works. Now, your quadratic formula really comes from completing the square. So your quadratic formula completing the square will always work. So let's go ahead and take a look at this. Your discriminant ends up being what's inside your root just from the quadratic formula. So if your discriminant, the b squared minus 4ac, is greater than 0, we have perfect square and we get two real rational roots. I mean, they might be nice normal numbers or they might be nice fractions. And so that would be like this here and like this here. It's going to cross in two normal spots. Or here and here on this problem, whether your parabola is opening up or down. Now, if your discriminant, when you plug it in, ends up being positive, but not a perfect square, then you get two irrational roots, because when you end up trying to simplify this thing inside your square root, you're ending up with a square root, and square roots are referred to as irrational numbers if they don't end up being nice and neat. And so these are two examples where when you work it out exactly, you'd have a root in your answer. It would not factor. The only way to do it would be with completing the square or the quadratic formula. Now, once in a while, you'll get it where your discriminant ends up being 0. That means your parabola touches your x-axis at one point, like here or here. We would then say we get one real rational root. Now, we had also talked about before, when your parabola doesn't touch the x-axis, you get i's. So if your parabola is always below or always above, you get i's. That means your discriminant is negative, because you'd have the square root of a negative, and remember the square root of a negative gives you an I with some other stuff. So your discriminant tells you all this information, the types of roots that you should be getting. So let's go ahead and find our discriminant. So remember, your discriminant is the b squared minus 4ac, and it has to be equal to 0 first. So your b is what's in front of your term to the first power. Your a is what's in front of your squared term, and your c is the number that's added or subtracted. So if we plug that into your discriminant, you'd plug in your b, you'd plug in your a, and you'd plug in your c. Well, when you work this out, we get 49. Now, 49 is positive. You now have to decide, based on what we just looked at, it's positive. Is it a perfect square or not a perfect square? Well, 49 is a perfect square. It's 7 squared, so we get two rational roots according to what we just looked at on the previous slide. Well, we need to do the same thing here on the next one, but you have to have it equal to 0. So you'd have to go ahead and add 10 to both sides before you can find your a, b, and c. So your b, once again, is what's in front of your term to the first power, which is 5. So I have to go 5. Your a is what's in front of your squared term. Your c is what's by itself. So then remember, you have to have b squared minus 4 times your a times your c. So we plug in our a of -8, plug in our c of -3. We can plug all this into our handy-dandy calculator, and we get -71. Since it's negative, that means we would get two complex, meaning we'd have i's in your answer, roots. Roots, solutions, zeros, all mean the exact same thing. Now, this negative, or b squared minus 4ac, all comes from your quadratic formula. It's what's inside of the root of your quadratic formula. What we were just looking at was this part here. That's your discriminant. The rest of this is your quadratic formula. Your a, b, and c you still find, but you have to have it equal to 0 first. And now the quadratic formula allows you to be able to find your exact solutions no matter what's going on, where factoring only sometimes works. So we can identify our a, b, and c. So your a, when it's equal to 0, is once again in front of your square root term. Your b is here. And your c is what has no variables. So you plug it into your quadratic formula. Opposite of b, plus or minus the square root of b squared minus 4 times your a times your c over 2 times a. So you plug in your 7 for your b's. You plug in your a in both spots, and then your c only goes in once. So all we're going to do is simplify. Opposite of 7 plus or minus. Now what's inside of your root, go ahead and type that in all at once into your handy dandy calculator, and you get 625. And then you can figure out the bottom, you get this. Now check to see if the square root of 625 works out to be nice. In this case it does. So you can plug that into your calculator and you get 25, still over the negative 12. So now I'm going to write it as the two separate possible answers and simplify each one. Once, write it out with the plus, write it out then with the minus. So you work out the left side, you get 18 over negative 12, and that simplifies down to be a negative 3 over 2. And then you do the other side. You subtract the top, you get negative 32 over negative 12, and that's an 8 over a 3. So these would be your answers. So we're going to continue this, but remember we have to have it equal to 0. So I'd have to go ahead and add a 6x squared to both sides. And I'd have to add a 7 to both sides. Remember, you can only combine together like terms. So we get a 9x squared minus a 4x plus 8 is equal to 0. So remember that what's in front of your squared term is your a, b is what's in front of your term to the first power, and then c is the one that's all by itself. And then we can plug this into your quadratic formula. Opposite of b plus or minus the square root b squared minus 4 times your a times your c. You'll notice I'm always putting down parentheses for my input. That does make a difference, especially when you're plugging it into your calculator. Then you plug in your b, plug in your a, plug in your c, and then you're going to simplify. Opposite of a negative 4 is 4, plus or minus the square root. On the bottom we get 18. Now take and type everything in that's inside the root into your handy dandy calculator. Now we have the square root of a negative, so we can pull that out. We know it's going to be an I. And then you have to take 272 and simplify it like you've done in the past. So if I take 272 and do my factor tree, I know 2 goes in there because it's even. 2 goes in there again. 68, sorry about that. 2 goes in there again. And then 2 goes in there again. So I can pull out this pair of 2's, I can pull out this pair of 2's out of my root. Pull out a 2, and another 2 really gives me a 4 in front with my I. I didn't do anything with that 17, that stays there, over 18. Now, I can go ahead and simplify a little bit more. I can pull a 2 out of the top. I could pull a 4 out, but 4 is not going to help me with that 18 on the bottom because 2 doesn't go in there. I'm left then with a 2 plus or minus a 2i root 17. When you have 2 times the top and 2 times the bottom, you can cross those 2's out, and then what you're left with then would be your final simplified answer. That's solving by the quadratic formula. So now all we're going to do is one word problem. So go ahead, pause the video, read through this. Well, now that you've read through it, we know when we're looking for this, we need our height to be 0. And so that's why I replace my y value here with 0. So to find your discriminant, remember you need to have it equal to 0, which we have. So your a, once again, is going to be what's in front of your squared term. B is what's in front of your x to the first power. Well, we don't have anything, so that means your b is 0. And then c is the number that's all by itself. So we can plug that into our discriminant. We plug in our b, plug in our a, minus 0.00009. Wow, I didn't really leave myself enough room. And then plug in my c. Well, when you type this all into your handy-dandy calculator, you get a negative 0.078, or 2. Now, remember, that means you would get i's in your answer. That means your parabola would either be always above or always below your x-axis. Since we have a negative in front of our squared term, we know that it would be like this here, where your parabola is always below the x-axis. It would never touch your x-axis. So what's that really tell us about our supports here? It means that the cables never reach the height of 0, because we ended up with a negative, which once again, we never touch our x-axis when we have the square root of a negative. Now, if we would have ended up getting a positive here, then that would have told us when these do touch the x-axis. So our cables never get to a height of 0.